Hello everyone, welcome back to Express VTU for all. So today we are discuss a very important problem from module 1, probability distribution. This is a very important problem. You can easily score marks from this problem. So the question is, find the mean and variance of the binomial distribution. So mean is nothing but expected value, which is E of x equal to summation of x equals to 0 to n x into p of x. So this is the form of binomial distribution, p of x. So p of x equals to ncx p to the power x q to the power n minus x. So put the formula of this in this equation. So mean equals to summation of x equals to 0 to n x into ncx p to the power x q to the power n minus x. So first we expand this ncx, which is equal to n factorial divided by x factorial into n minus x whole factorial. So summation x equals to 0 to n x into n factorial divided by x factorial into n minus x factorial p to the power x q to the power n minus x. So n factorial we can write as n into n minus 1 factorial. Like that we can write x factorial equals to x into x minus 1 factorial. So put the value of n factorial x factorial on this respective place. So summation of x equals to 0 to n x into n minus 1 factorial divided by x into x minus 1 factorial into n minus x factorial p to the power x q to the power n minus x. So this will cancel out. Summation of x equals to 0 to n into n minus 1 factorial divided by x minus 1 factorial into n minus x factorial. We can add it p to the power x squared p into p to the power x minus 1 q to the power n minus x. So we can take it outside n and p. So np summation of x equals to 0 to n minus 1 factorial divided by x minus 1 factorial n minus x factorial p into x to the power n minus p to the power x minus 1 q to the power n minus x. So when x starts from 1 to n minus 1 factorial divided by x minus 1 factorial into n minus 1 minus x minus 1 factorial or factorial p to the power x minus 1 q to the power n minus 1 minus x minus 1. So np summation of x equals to 1 to n. So this is nothing but the formula of n minus 1 c x minus 1. When you expand it, you can easily get this step. So this is n minus 1 c x minus 1 p to the power p of x minus 1 q of n minus 1 minus x minus 1. So what is this whole equation become? So this is nothing but derivation of binomial theorem. So it becomes mu equals to np p plus q to the power n minus 1. So we already know that p plus q equals to 1. So mu equals to np p plus q equals to 1 to the power n minus 1. This is nothing but mu equals to np of 1, which is equal to mu equals to np. So this is our mean derivation. Now we go for the variance. So now we go look for a variance. Variance v equals to summation of x equals to 0 to n x square p of x minus mu square. Already we know mu equals to np. So this is the expected formula for variance. So now we solve it. Summation x equals to 0 to n x square p of x. First we take up to this, later we know the value of this one, so we can easily subtract from this expression. So how can we write x square? We can write as x into x minus 1 plus x, because we can multiply it x square minus x plus 1, this will cancel out, this is become x square, like that. So summation of x equals to 0 to n x into x minus 1 plus x and p of x. So this is two terms, first one is this term and second one is this term, so we can multiply p of x in these both terms. Summation of x equals to 0 to n x into x minus 1 p of x plus x into p of x. So now we can multiply summation of x equal to 0 to n on these both terms. We can separate it. So x into x minus 1 p of x, here summation start x equals to 0 to n plus summation start from x equals to 0 to n x into p of x. We know that already derived this formula. This is nothing but mean, which is equal to np. So summation x equals to 0 to n, we need to solve this expression because already we know this expression. So x into x minus 1 into p of x, we already know that p of x is nothing but ncx p to the power x q to the power n minus x. So summation x equals to 0 to n x into x minus 1 ncx p to the power x q to the power n minus x. So summation of x equals to 0 to n, here what term is there, x into x minus 1. So further we expand this formula as our requirement. So n into n minus 1 factorial divided by x into x minus 1 factorial into n minus x factorial, p to the power x q to the power n minus x. So if we cancel out, we are not able to cancel n minus 1 factorial to the x minus 1, x minus 1 factorial to the x minus 1. So we further extend another step, so which is summation x equals to 0 to n x into x minus 1, here n into n minus 1 n minus 2 factorial, like that x into x minus 1 x minus 2 factorial x n minus x factorial, p to the power x q to the power n minus x. So like that this will cancel out. So summation x equals to 0 to n into n minus 1 n minus 2 factorial divided by x minus 2 factorial, here n minus x factorial. This is, we can write it according to the mean, p square into p of x minus 2 q of n minus x. So we take n minus 2 n into n minus 1 and p square take outside from this summation. So we get n into n minus 1 p square summation of x equals to 0 to n minus 2 factorial divided by x minus 2 factorial into n minus x factorial, p of x minus 2 q of n minus x. Summation of summation of x equal to 0 to n. So like that n into n minus 1 p square, summation start from x equals to 2 to n minus 2 factorial x minus 2 factorial n minus 2 minus x minus 2 factorial, because our x starts from 2, like that p of x minus 2 q of n minus 2 minus x minus 2. So n into n minus 1 p square, summation of x equals to 2 to n. This is nothing but the formula of n minus 2 c x minus 2. And then remaining is p of x minus 2 q of n minus 2 minus x minus 2. So n into n minus 1 p square. So this is nothing but the binomial theorem. So the equation become p plus q to the power n minus 2. In the mean, you can clearly see that here is n minus 1 according to the x value, from where x starts from 2. So plus NP. NP is, this is NP. So the equation become n into n minus 1 p square. P plus q equals to 1, already we know. So 1 into n minus 2 plus np. So this is nothing but n into n minus 1 p square plus np. This is our summation of x square. P of x equals to n into n minus 1 p square plus np. So now in this expression, here is mu square is also there, which is mu equals to np. So subtract mu square from this whole expression which we obtain. So like that, n into n minus 1 p square plus np minus np whole square, which is equal to mu square. So like that, we multiply. First we multiply this. So n square minus n into p square plus np minus n square p square. So multiply p square in these both ends. So n square p square minus np square plus np minus n square p square. So n square p square minus np square plus np minus n square p square. So from this whole expression we take np as a common. So this here become np minus p plus, this is only 1 minus np. So this np and this np will cancel out, then become np of minus p plus 1. Already we know that p plus q equals to 1, then q equals to 1 minus p. So what is the value of 1 minus p? Equals to q, where np, this is value of q. So variance is nothing but npq. If we are able to, if you are looking for standard deviation, this is nothing but sd equals to under root npq, or we can consider under root of variance. So thank you for watching this video.